Okay, before the break, we started looking at Godot Engine, and right before I started the recording, I guess I should have waited. During the break, there was a couple issues with controls and stuff, getting used to it, and so we're gonna have a lot of time today just to click around randomly, like we're doing in class now. Not, I already know what I'm doing, so ours kind of came together very quickly into the basically the default state Godot is set up for, right? If we wanted a first-person game, everybody realizes all we need to do is move that camera forward, right? Whoops, wrong arrow.
Put the camera in the face.
Blue arrow, yeah. Move the camera here, and if we have that's first person. Okay. Yeah. A little further forward. We all get the idea.
It looks like
Control Z is undo. That'll probably it's the normal Control Z for undo, Control Y for undo for redo.
That little because like a flat panel and a triangle I think that pyramid point is where the quote unquote physical lens is. If you look at that.
Yes, the poker it has to do with how it's processing it.
Yeah, that's where it's actually looking from. It's that little point there where everything goes back to.
It's kind of the middle of it.
Is it?
Yeah. So with 3D graphics, camera, yeah. So we take a cube of space. Take that's supposed to be a cube, a nice evenly spaced cube, and turn that into a frustum, which is like a pyramid with the triangle cut off. So we take the cube and scale it like this, and that's how we get our three-dimension thing, if that makes sense. So the camera, they continued the graphics on out to a point, but it's that compressed view that we're looking at for three dimensions. And then that's how things resize as it goes out. If you've had a linear algebra course, and you'd know what transforms are, you would have seen them in a linear algebra course. But if you've had a linear algebra course, it's really, really easy to go to the math for that. It's not super complicated, but if you just go and Google it, it's going to look awful.
I just did animation software too.
Huh?
I did animation software too with Sports Filmmaker.
There's lots of alternatives, and that's not the only way to do it, but that's what we typically do, because then we can drop stuff off. So like the big end becomes the front that's close to us, the small end is there, and you can see that the middle is the actual size of the cube. So things get closer, stretch out, and things further away get smaller. And then there's some processing that happens too, because the stuff that's real far away, we don't want to bog down our GPU. We don't want to have our GPU processing every single detail if it's way, way off in the distance, where there's no way we could see all the details anyway too. But that's a very important shape. Okay, yeah. So back to our example, we put a couple of meshes in here, some twin static bodies, and we have the arrows where we can move things around. Doesn't work on the WASD keys after we much for them, and the space jumps, and that's sort of the default character movements that come with that character script template. And look at it. I think first thing I wanted to show before we change the inputs though is notice how the speed is set to a constant. I like to change that. So it's based off Python, but there's a few other things. We have to put in a keyword to state where we're declaring a variable. And it's also, it's either dynamic or strictly typed. And if it's strictly typed, it will run faster. So if you put a colon, so var means we're going to create a variable. We'll call it speed. And actually, I'm going to push Control R for find and replace and make that lowercase. The convention is constants are all uppercase, now hit replace all. And then a colon, and then we can put the type. Say it's a floating point number. And then the assignment. So when we put in the type, one of the things that makes Python really, really slow is the computer has to waste a bunch of time trying to figure out what type of data it is.
Wait, did you have that on map or player?
Oh, it doesn't matter which selected
Oh,
because the scripts are, we only have,
I see.
we have lots of text files.
You have speed, space, colon, what?
Float. Is that better?
I'm confused very.
So I took that, rewrote the line there at the top. They had speed set as a constant.
Oh,
I changed it to that. I'm gonna highlight jump velocity and hit Control R and change it to lowercase. Yes. Then a colon, and this time we also have the reassign those assigning operators or reassignment operators. We can use that for type. So if we do colon equals, it's going to figure out that's a floating point number because we have the decimal there. So two ways to declare what type it is, but it will run faster if you declare the type. Otherwise, the computer has to come up with a type. And it compiles to C++, and we have variable type in C++, but we lose a lot of speed with variable type because the computer has to figure out what it is.
So it's kind of like dumbing it down to the computer.
Mhm.
Getting it ready to complete.
Yeah, because we know what type of data we have.
So the one that you did for speed is faster than the one you did for.
Oh, they're exactly the same. So what's in the text file is not what passes through the CPU. So that's an abbreviation, right? The standard one, X is assigned X plus 1. We can say X plus equals 1. And when it passes through the CPU, those are exactly the same, right? So it's that sort of syntax.
Yeah, but what you did here is, but you were talking about variable versus constant was.
Oh yeah, constant is set to so that it doesn't change. I wanted to change it to a variable. We might change, and our speed might change. Actually, the speed does change because the laws of physics are applied. When we let go of the key, it slows down from friction. It doesn't just stop moving like what we did in Game Maker. So there's two alternatives. If we know what type of data it is, go ahead and type it. But sometimes we don't know what type of data it is, or there are certain places where we can't say in advance what type of data it is. So like collisions could be lots of types of data. Right now in our game, a collision could either be player data or ground data. So if we're going to check every collision that happens, we can't say in advance what it is. That's when we need the shortcut one. Keep it strictly typed, and the computer will figure out which one it is. But if we know explicitly what it is, we can go ahead and type it. The main point, and you can leave the type off, but it is faster. Strictly typed languages are faster than dynamic languages. That's across the board and on every computer, everywhere, in every programming language. If the programming says what type it is, I'm going to add another word rep form though. Let me highlight the player. So if you keep an eye on the inspector panel here, you look up at the top of the inspector there, and at the beginning of line 4, add export, and then a space, and then all that. Script in the right place. Where's that not showing?
I think so. Is there something wrong with the variable names? Because that's getting an error. It says parsing.
Jump velocity dot declared.
Oh, I forgot to hit replace all. So to fix the errors. Instead of replace, I'm gonna hit the replace all button. Then I'm gonna
There's a,
or you can keep it in all uppercase. I just wanted to type it there. But notice now that export
Oh, yeah.
put those into the inspector panel.
you get the replace all.
If you highlight the word and hit Control All or Control R, there's your find and replace.
Oh, you're talking about, okay, I see.
Yeah, and then you can just replace all the words at once. I just always do that because the uppercase does not match with anything else in the code. But if we add that export, notice how it adds it to the inspector panel. That's where all the stuff in the inspector panel came from. So if we need it, you can also click and drag up, gives it to us as a string, because most of this stuff is keys. So right click and hit copy, and notice we have multiple copies. Copy value, paste value, or copy property path. I click copy property path, it gives us that variable name, but that one's probably not a good example. If I come down here someplace, like down in the input and gray pickable, if I click this and copy property path, and then come over here and paste, notice it gives us the full path of how to get to that. Something so okay. But if you click on the position, copy property path, and paste it. Paste that in, I guess that's just position. We'll see how to read those more, but you can see we can get those values from there. If we wanted to refer to the ground for some reason, I can click and drag that in. It gives us this syntax $sign with a string, which is just part of it. If I click and then hold Control and drag it in, this is the whole syntax of how to get it. Even stored it in a variable for us. We'll talk about what onReady is in a moment.
So click, then hit control and drag it in.
And then the $sign followed by a string is the syntax to get to that. So notice the file path that goes up a dot slash. So the first dot is the current location. Second dot is the parent. We're going up the tree. And then slash, we go back down the tree somewhere else. So in this picture here, it's like we go up the tree, or we go up the tree back to the root, and then down a different branch to get to the ground. So you can type it in there, but we can drag and drop code into our script. Let's look at what's going on here. So notice gravity comes from project settings. I'll get rid of the code that doesn't do anything. Add the gravity that doesn't do anything. So if we're not on floor, our y velocity changes by the gravity times delta, or by what delta is here showing up. Then this thing about handling the jump, it helps out the basic sputter here. There's our input direction. Notice that it's looking for an action press, then UI accept. And well, we know that's jump. We already seen our character jump, right? So that name was just built in there. UI left, UI right, UI up, UI down. Apparently those are the arrow keys because that's what moved it. This is the important line though. We can get rid of this line in a moment. Something different. Transform.basis. So basis is, I'll draw a picture on the board.
Use my code. I think I wasn't able to follow it.
We're just pointing at stuff.
Okay.
Yeah, we're just previewing it today.
Okay.
We'll talk about it more later. So like in math class, everybody's seen the X, Y grid and doing all the stuff that way. But is there anything that stops us from saying that direction's Y and that direction's X? Yeah, we can point any way we want. Those are arbitrary limits. Same thing in 3 dimensions. That's the basis. It's here, maybe for some reason it's more useful to have the 40, the way this picture is, have the 45-degree angle, what we would consider 45 degrees at the perfectly horizontal. There might be reasons for that. So the basis is that arbitrary labeling. How is that directed? So what the code's doing there, once we get this part, that's just grabbing some stuff from the inputs. What those do, that grabs in each of the inputs, gives us a number somewhere between -1 and +1. Like the arrow keys, when we first push the arrow key, it's at 0, and then it quickly accelerates up to 1 or -1. None of it's left or right. Same thing for up or down. Or from 0 to -1 for left, or 0 to +1 for right. So we have that value, and then we can use that map. So basis is the direction we're oriented. So it might be straight with the world axis. It might be rotated around slightly, and we get a new coordinate axis for our particular object. And then we multiply that by whatever we got from those inputs. And then this one here, then normalize, we take that vector and then divide it by the length so that it's actually length 1. And that gives us a new direction without any distance to it. So normalize just gives it a length of 1. So whatever vector we feed in there, right? Instead of, I said those are between -1 and +1. Maybe we feed in with like 32 and a 64. If we use those on a right triangle, that's going to be a really long hypotenuse, right? So we just divide it off so that the hypotenuse of a right triangle, you can think of it that way, is always length 1, so that it's just pointing in that direction. And then we can multiply that by the speed to figure out how fast we're going. Because if we're not pushing any keys, then that's 0, right? So we're taking the vector that describes the way we're oriented in space, the way we're facing, basically. And if we're not pushing any keys, we multiply it by 0, and the result of multiplying by 0 is going to be 0. Or it's vectors, so we multiply by a whole bunch of zeros. Have a whole bunch of numbers describing how we're oriented in space, and then we multiply that by a whole bunch of zeros, and we end up with a whole bunch of zeros. So that means direction would be false, right? If 1 is true and if 0 is false. So if there's computers only check false, if you haven't heard that before, it only checks if something is false. So true just means it's not false. So computers do not check both true and false. Right? 1 and 0. Either there's something small or not at all. So we can't check two things. So computers check false versus everything that's not explicitly false. That's what's going on in that if else here. If it is 0, then the move towards the built-in method that just kind of finishes out. Then we call this move and slide method. I always want to call that at the end. I hold Control and click on that. It pulls up the documentation. So all the documentation is built right in. If you weren't watching that, let me right click and close that file. They don't give us a little X for closing the files. We have to right click and close it. So I'm going to hold Control, and notice whenever I hover over things, they get highlighted. So I click on that. There's no documentation, so it goes back to transform and said it comes from there. Oh, and then there's what the transform 3D from a node in the node 3D element is. What's that?
So if you're wondering what in the heck something exactly is, if it autofills or whatever, or even if you want to figure out how to better utilize that command, you can just pop up its variable manual.
And as we add variables, we can do that too. I believe it. I have to do it in line. Let's see if this works. I don't think it'll work here because we only have the one script. Maybe that works. There's different syntax. I'm not sure which syntax they use here. We have to click on it down here. Oh, jumps up there. We can add to that documentation. It's dynamic. So it's your local documentation. So as you create new methods, control click, we can see the movement moves the body based off the velocity we set up. So velocity is speed with a direction. 55 miles per hour north is different than 55 miles per hour south. Interstate's right outside campus here. If we tried to go 55 miles per hour south, we're never going to make it to Indianapolis. So that's the difference between velocity and speed. The directions include. If it collides with another body, it will slide along the other body rather than stop immediately. If the other body is character body or rigid body, which are our other two types of bodies, we also have static body. Static's not going to move, that's solid like the ground. But a rigid body and a character body, when we bump into them, they're going to move, right? I can bump into this computer. Is that on the camera? Oh, it's not on the camera. I move this one up so you can see it. If I bump into it, it moves, right? So we want that to happen in our games. It pivots, it moves.
It's all.
Yeah, I didn't bump into like a stationary monitor. The ones monitors in here move very, very easily. But the control click pulls up your documentation. So save you some time from going and Googling things. Movement. UI accept, that's built in. That's not a useful word. Left, right, up, and down are good, except that it doesn't use the WASD keys. But we can do better than that. So if we go to project and project settings, and this is one you'll do almost every time in all of your big game engines. A whole bunch of stuff. See the second tab there? We'll see as much as we can before December 6th. When's our last class? 17, 16, 15, 14, 13. Before December 13th, we'll see as much as we can. But there's a lot going on here. Yeah, the semester ends on 17th, which is a Sunday. So on all your big game engines, the second tab here, input map. This is how we map our inputs. There's a little switch here, show built-in actions.
How did you get that?
So project and project settings. And yeah, we'll do stuff here just about every game we make. If I show the built-in actions, you can see UI accept. So we have the enter key, KP enter. I'm not sure where KP enter is, and the space key. For UI left is the left arrow, or the on a controller the left button, or on a controller push the joystick to the left. So we have three different options. We can do map multiple options to that one name for options. I'm just going to make some new ones. Let's say forward and backward. So wherever it says add a new one, you just type a name in and you hit enter. Shows up there. And for y'all pitch and roll movement, I'll do turn left and turn right. And for clarity in our code, I'll just rename that one to a jump input. Makes more sense that way. Then we can assign buttons to them. And these are called axes. They are called axes. Sometimes we use that word. They're dimensions in a vector. So when we talk about vectors, it's a collection of numbers that go together. So here's our input vector. We have 1, 2, 3, 4, 5 numbers that make up the input vector we're going to use in our game. And each dimension of a vector is also known as an axis. I know you all have heard about XY planes, right? The x-axis, y-axis, or which is made up of an x dimension and a y dimension. So when we put a unit of measurement on a dimension, that's when it becomes an axis. To get into the technical terms, but we will, in our code, we'll sometimes use the word axis. See how there's a plus sign over to the right of each one? You just push plus, and then this box pops up. What key do you want to use? You can search through them all, or if you just press the keys. So forward would be the W key. So just push that. It's something I still have never gotten used to. I just want to hit enter, but notice if I hit enter, it thinks I'm pressing the enter key. Same thing if you try to tab over to the OK button, it thinks you want the tab key. So press W, and you do have to click OK with your mouse. There's not a way around it, because anything else you press, anything other than clicking OK on there is going to make the computer think that's what you want. Backward. Notice mouse button. There's also mouse buttons, joypad, joy axes, and we can make new ones. Backward is S. Click the filter for event, and click the left mouse button if that's what you would rather. If you'd rather use the left mouse to move backwards, or right mouse with scroll wheel, or probably want S for backwards though. And then then you have to actually move your mouse cursor to the OK button and click it. Otherwise, it's going to listen for whatever you're doing. Left and right are going to be A and D. So turn left, use the A key for that. Turn right with the D key. And then jump, I'll put on the space, which is what it already was, but I'm going to change that in the code from saying the UI accept input to the jump input. And then we can set up a whole bunch of them, right? We'll set up different buttons on controllers. Turn on the plugins for specific controllers. So turn on like the PlayStation plugin, and then we have our PlayStation buttons. Y'all know what PlayStation buttons are. The labels on the PlayStation buttons. Choose those, or plug up a PlayStation controller. I think you have to turn in the plugin first. Plug it. Once that's on, then plug in the PlayStation controller and just listen for that event. But it just give it a name to use in the code, and then whatever buttons you want to use. Probably more than one, just one for us, but here's our jump, so now we can call that jump. And this line I'm just going to get rid of altogether and go with something a little bit more clear. So I'm going to create a variable called Z. So floating point number, and I'll start it at 0. This is the movement I like. Then we can check those buttons. So like if input.is, those two at the top, action just pressed or action pressed. So action just pressed only happens once, and action pressed will happen every frame of the game. So for moving forward and backward, we probably want the pressed. Jumping, we only want to happen once. So that's that. You can see it up above there. That's the is action just pressed. But is it action just pressed forward? Whoops. Picked the wrong thing off the predicted list, so I'm just going to type it forward. And it's like Python syntax, so then we do a colon and indent the block for that selection. If it's forward, we'll set Z equal to, anybody remember which direction on forward is? Is it positive or negative Z?
Negative.
-1. And it's one or the other, so a lot of times I won't even bother to remember. I'll just type it. I won't even bother trying to think it through. I'll just put these signs on arbitrarily, and if it moves backwards, I'll change them on the next thing, because probably don't want to do else though, because there's a whole lot of else's from just the forward button, right? Whoops. Didn't mean to press that button. So elif input is action pressed on backward, then Z will equal the +1. Notice how it's one or the other. You will see a a lot more of that when coding your games. There's a lot more if elifs and not so many else's. Because if, in the else case, that just we don't do anything. But there's a whole lot of situation, whole lot of things we need to check. Then our next block is for turning. That'll get our forward and backward, right? And we can turn and move forward at the same time. So I'm going to start a new if block instead of another elif. If you're in a situation where you don't want to be able to move forward and turn, a tank might be a good example, right? Because tanks turn by stopping the tracks on one side. So you can't move forward and turn in a tank at the same time. Because that turning a tank is based entirely off stopping one of the tracks, which is what moves it forward. So, and then the other one tries to move forward, and then that causes it to turn. So in that case, you'd probably put, if you were setting up motions, similar movements for a tank, you'd set an elif. You wouldn't want to be able to turn while moving forward. But for walking, we could. So if input is action pressed, and hopefully no surprises on this. Let's say turn left. Colon, I'm gonna type the word pass so I can type the whole thing about the condition first. If input dot is action pressed for turn right, then pass, just fills it in to make the error messages go away. Right, when we have an if, so after if we have to indent something. So pass, if you haven't seen that before, pass is just the keyword for don't do anything, but the syntax requires us to put something indented there. And then that's useful for writing code. Then we can come back. We think about our entire selection structure, the conditions for it, and then we come back and worry about the blocks one at a time instead of changing our mind back and forth. So there's our conditions. And what I want to do is change the rotation. So we have that in our transform, right? I go to player. I want to change rotation around the y-axis. So I want this property right here. So transform is so common, transforms automatically apply. Some of the other ones we would need that main section there, but transforms our main thing in game development, so that's applied. So we can come down and grab the rotation, which you all probably already guessed the word. But notice how over here it's spelled rotation with a capital R. If I right click and copy the property value and paste it in, it's rotation with a lowercase r. Let me copy and paste one of these down here. So notice down later there's rotation editor. 2 words with a space and capital letters. If I right click and copy the property path, and then I'll just paste this down here somewhere. Come in here and paste that. Notice it made it lowercase with underscores in the code. So if you're looking for those words, everybody see that translation from the nicely formatted label into the code.
So can you do that again? I was doing.
So rotation editor here, rotation edit mode. If I right click on it.
How are you getting?
Oh, so with player selected, then expand the transform.
Good.
Make sure that the transform's expanded, and then just right click on that property, and there's copy property path. You copy that, and then come over here and paste it. Because here it had capital letters at the beginning of each word and spaces between them. And then over here it's snake case, if you haven't heard that word before. All lowercase letters with underscores called as snake case. But you see how we're able to get the words we need for our code right from the inspector. The labels are already there. that functionality is why Godot gets ranked with Unity and Unreal, because those are the only three that have that. Everything else uses different labels and our labels, and we can't like grab rotation, hold control, and drag it over there. We got any. So rotation, and then in that rotation section, there's three things, right? X, Y, and a Z. So we can say rotation dot Y, and we'll assign that to whatever rotation dot Y was. Plus, and we just need to put an angle here. But over here, it's formatted in degrees, but when we type it in the code, it has to be in radians. Just a different way to measure an angle. A radian is like a degree is at the center. If you think of like a wheel, a degree is turning around the center. So, but it doesn't have any length with it. So if we take the length of the radius and go that far around the outside of the circle, it gives us a second way to measure an angle that includes a length to it. It's usually more useful. So in our code, we have to enter radians. There's a function built in that we'll use for that degree to radians. For those who've had a trigonometry class, that function just multiplies by pi 80. Simple, the normal conversion, but everything abbreviated in it, in snake case, degree to radian, and then maybe we'll turn 15 degrees each time. Then I'll copy that down. And I spelled it out there fully, but we do have that shortcut syntax, right? Rotation dot Y plus equals that other one. For the example here, it's probably a little bit clearer if we spell it out. And
That would be -2.
yes. Which one? So that's a good question. That was the next thing I was getting ready to say.
That's the second one.
And really, there's only two, so it'll be obvious if it's backwards, right?
Or only negative on that, like negative.
Oh, it would be the same. We'll get the same thing here. So plus a negative number becomes minus. Because we might want to change that. We'll make some changes, but yes, we can put the minus in several different places. I just put it at the positive and negative angle. And that might be the wrong positive and negative, but we will very quickly be able to tell, right? If we push the A key and turn to the right, means the negative, we put the negative on the wrong one. So that's what I usually do instead of thinking through which one it is.
Just slap something in and you'll figure it out the moment you try it.
Yes, the only reason I ask about the positive and negative Z direction is because we've already talked about that today, and that's an important one to remember. Especially when we start doing things with Blender models, because Blender uses negative Y as forward. And Godot uses negative Z as forward.
So then.
Yes. And luckily, both of these are clockwise rotations. Blender to Unity was the same thing, except it was negative Z, and Unity uses a counterclockwise rotation. So it's completely reversed.
So the fact that this has this is designed to interface with Blender, it has it automatically can draw from Blender. Does it automatically understand that there's that there, or do you have to keep that in mind while you're working?
We click checkboxes in Blender.
Okay. So yeah, they can talk to you enough for you to fix that without having to be constantly remembering your code.
Yes.
Okay.
Yes. Blender to Godot will automatically switch your Y's and your Z's, and your X stays where it is. So those work good, but there's checkboxes in Blender we have to do for everything else. So that rotation gets our basis, right? So like here, I have some basis for the direction I'm facing. So forward is towards the camera, I guess. But if I turn 15 degrees, now forward is off to that corner of the room. So that's the basis. We're walking up a hill and lean backwards and turn. So now that's what forward direction is. So we have two different things. So our basis, the way we're oriented, our current coordinate system, basically. Where do we redraw our axes? And then we'll multiply by some vector. Now, like this one, we're walking, right? So we're only moving in that forward, backward direction. We don't have to necessarily worry about the left and right. Might want to work something in, depending on how abstract you want to be. But the way this is set up, if we wanted to move to the right, we turn right and then go forward, then do forward. That's the type of movement I like to go with. And it introduced a few things there. Hopefully that made it a little bit clearer than what that generic version was. And that gives us a direction. If we're not pushing forward, then that's all zeros. So that means our direction is 0. And 0 is false. So that is explicitly false, which is the thing computers check for anytime we give them a condition.
It's giving me an error that C is not in the general scope, which I don't know if to find a buffer.
And then up here.
That's up. I think it's
Yes, so it does have to be declared somewhere.
still giving me an error though, because I just tried to unindent it and it just get the if statements from it.
Well, it's based off Python, so indentation matters.
Well, that's why I did backspace from it.
It has to be the same indentation.
Oh, I know. Yes. No.
What's that error message say?
Well, when we go backward, it will say expected statement thing instead. And then when you type, it goes on identifier as Z can be declared the scope, current scope. Yeah, I don't.
Are you inside of the function here?
Yes.
We'll look at it in a moment. So I'm gonna go ahead and run this and check those new movements. So jump space works, but the enter key no longer works for jump. I guess I didn't show that before. Remember how we had several options for the UI except that it originally was. So now we're only have the space bar. The arrows aren't there. It might not hurt to put the arrows to those inputs we named. Turning's fast. But S and W work in the right direction. If I push D, I think that's the right way. It's just going really fast. So that's this one right here. So notice how whenever we have that method where we put all of our code in, called physics process. So let me talk about our 3 methods. So there's going to be one called _ready. And this, I'll just put a label here. So ready runs 1 time at initialization. And then we have another core method. So notice that keyword func changing from Python where we use def for short for define. We use func as in function. We're going to create a function. _process is one that's built in, and it takes in this parameter delta. And what this does is runs each frame of the game. And the second note here with graphics priority. Then I'll put the keyword pass, make the error messages go away. So initialization, I think we've seen a couple times so far this semester, right? We initialize things and then we do things at every frame of the game. So I'm going to copy this, paste this down here. You may guess what I'm going to change that word to. So process gives us graphics.
Physics.
Yes. Physics process gives us physics priority. And it's not like one's going to be abandoned over the other. And your game is probably going to have to get really, really big before it has to get absolutely massive before humans notice the difference between them. But whenever you have a game that is large enough that you might need to back off something, right? Way too much processing to fit in a particular frame of the game. Do you back off the graphics or do you back off the physics? So obviously the answer to that's different every game, right? Depends on your game, but which one do you want to give priority to? And until your game gets huge, the difference between them would be nanosecond. We're talking nanosecond difference between them. But also helps with organization. And then that delta keyword, delta is the length of time the previous frame took. So it runs the code at the beginning of the frame, right? Checks all the code, gets it ready to run. So we don't know how long that frame's going to take, but since the computer's trying as hard as it can to hit that frame rate, to average out to that frame rate, the current one should be about the same length of time as the previous. Really, really close to it, right? So that's the length of time at the previous frame. So, well, they did here. So we have gravity, and that's stored as 9.8 meters per second squared per second. 9.8 meters per second faster every second. But there's so many frames, we multiply that by the length of time in the previous frame rate to get something meaningful for our game. And we'll do the same thing with our angle here. So we multiply by delta, which is just going to be a really, really small number, right? If we're doing 140 frames per second, well, 100 is easier for the math. Let's say we decide to set our engine up to run 100 frames per second. That's easy for math, for example. Then each frame, the computer's trying as hard as it can to get all the processing done in 100 milliseconds. Some of them might take a little bit more, some of them less, depending on what's going on in the game and what's in view and what the player's doing and all that stuff.
Craziness, the player just unleashed.
Yes. So it's going to vary a little bit, but let's say it's around 100 milliseconds. So we take this rate of, we're thinking 15 degrees per second. So speed we're turning, and then we multiply it by that 0.1 small number to get a small number of what we want to do each frame. Now our turn should be better. It's going to be really slow. 15 is pretty slow. Luckily, we have the corners so we can judge things. When I was getting ready, I was going to put some squares and circles there so we could see stuff, but because we can see the corners to see which way we're going, forward, back, forward, turning. Might want to put that on and something like that. We might want in our inspector so far. Turn velocity, I'll call it that. So the number, the floating point number will start like 15. Well, 15 is just 32. But now it's over in the inspector panel, so we can change it. Right up at the top there. So in the game. Forward, turn, if I move and turn, that turning looks slower than the forward move.
Don't you need to?
I'm gonna up that to maybe like 64.
Well, no, don't you need to add terminal velocity now down into your?
Oh, yes.
So it knows to look for that.
Yes. Thank you. So I add that in there and notice how it, and then negative turn velocity, and notice that our variables do show up on the predictive text too. So it is dynamic predictive text, is not locked in place. If I do the control click, I didn't put any documentation here, which I guess is a doc string afterwards. Might be a doc string in the same line, doc string before. I can't remember what notation they use for it. I almost never do that. But notice how it went pick up to where that control click for the documentation still applied there. So positive turn velocity, negative turn velocity, everything there making sense? Let's look at the player and notice the game's still running. I need to close that, run it again.
But let's say you got relog every time you make a change, don't you? It won't last.
In the code, yes. But that's why I put it in the inspector. So I can turn right. That still seems a little bit slow.
The inspector panel will.
So yes, I can change this to a 40, it'll be 48. Make sure you hit enter. If you don't hit enter, it doesn't go through. Now I can jump back over to the game and it's turning faster. I guess I could have gone way faster to make that more evident, but the inspector panel will do lifetime updates. Much better with two screens, and that way you don't lose, it doesn't disappear the way it does on the screen share here. But that's very useful for debugging. And notice when I close the game, it keeps the last value in there with the little reset symbol, and the reset symbol puts it back to what's in the code. So what's in the code is just the default. We can type anything in there, lifetime changes. I think that's about what I wanted to do there. What did I have in my notes? I wrote stuff down. So 3D plane and a capsule, character body, WASD for control, jump movement, third person camera, but a first person camera. If we move that forward, we would have a first person camera. That was a very easy change. Get started in script with the ready, process, and physics process methods. So normally we'll just choose one of the physics or the physics process. That's the biggest change for those this year that's left Unity after years, because Unity gave us the time and frame. Unity, we could do the initialization, and then we could then we chose whether we wanted the beginning of the frame or the end of the frame. Unreal follows suit here. We have initialization, and then we choose whether we want graphics or physics process. For using Unreal, we probably want graphics priority. Set process. Do we want graphics priority or physics priority? And until our game gets massive, we're talking nanoseconds between. But once it does get big enough to the priority could be noticed at human timescales, what's more important? A little glitch in the graphics? Like, is it okay if your character goes slightly into the wall before the physics take effect? Or is the physics taking seeing that in the graphics more important? Obviously very situational, and for most frames of the game, it's going to run fine. So that's like when there's glitches. When when the game engine has to choose what code to drop. Is it going to drop the physics, or is it going to drop the physics or the graphics this frame and pick it up in a couple frames when it gets back on track? So to prevent a total crash to the game, which one do we give up on? Which one do we keep? Physics or graphics? And then the engine will catch up as soon as it has a chance. But obviously, your game has to get pretty big. I teach at community college, so I use the cheapest machines at Walmart. And my PC is the cheap. I will go in there and ask for the cheapest PC. My Mac, I had walked in and asked for the cheapest MacBook. My Chromebook, I walked in and asked for the cheapest Chromebook off the shelf at Walmart, because I figure if it works on those, then the stuff's going to work on anybody's machine. Linux stuff is just old machines, but it's our virtual machines. But on my computer, it'll handle a pretty big game before it starts doing that. Cheapest one at Walmart, open the task manager. Does have the GPU. Yeah. So the cheapest laptop off the shelf at Walmart does have GPU on it. So the small one, not a lot of GPU, but that's something we can, for game developers, that's something we can count on being on machines. Not on the ones in the lab here. I brought that up to everybody. This was going around. I probably talked to over 100 people around the state bringing up GPUs with about that list. But I'm trying to get some external GPUs, like the shaders I have in mind. With Godot and Blender are on these lab computers, by the way. The shaders I have in mind, we can one or the other, but not both. Do clouds in the sky or ripply water. These computers won't do both at the same. Both won't do both of them without a GPU. So I'm still working on GPUs, but we get computers first. Y'all didn't know that in School of IT. So we get computers, and then in 2 years, when we get new computers, these go to the other architect computer lab. So we get the first ones. Still no GPUs, but I'm working on external GPUs. The cheapest laptop at Walmart has GPU. My cheapest Chromebook from Walmart has Intel embedded GPU, the virtual GPU stuff. So it's something we can kind of count on.
One thing that doesn't have GPUs are full computers.
Yes.
That's not the only place that it's not present.
Yes. And it's not just used for games. Anytime we're moving lots of stuff, it's great for data analytics, machine learning. It'll cut hours off of stuff. It's going to take 8 hours to train your model with the GPU. You got to leave it running all week with just a CPU. So that's what I want to do on the 3D. I also wanted to do a 2D pass. I think I'm going to do that one quickly because this is going to be recorded, and the recording will be available 5 minutes after class. And I can go through these steps now that we've seen them once, go through them fairly quickly, quicker than the normal follow along would be. And then y'all can check the recording afterwards and then do some random clicking around to get started before following the tutorial. So I'm going to go ahead and close out of this. Anybody have any questions on starting? Probably a lot, right? You want to start clicking around, start doing stuff. This is recorded. But see how quickly we were able to get that going? The explanations and everything. 2D is kind of the same way. So I'm going to go back up. I drew some little squares this morning, so I'll use those squares for 2D. That was for my test one this morning. Let me go back over to Godot. And then this is going to be a little bit quicker, so it's being recorded, so maybe follow along the recording after class. That way we can finish up with at least an hour of time to do stuff. So I'm going to do a new project, and this one will be class 1 2D. Create the folder, stick with the forward plus rendering pipeline, get for our version control, and create and edit. Okay, we didn't activate that. Version control stuff is built in there for those who had it, who are familiar with that. And there's multiple ways we can do it. I think your tutorial does some different stuff, but you don't have to perfectly follow the tutorial. Or remember, please don't perfectly follow the tutorial. Customize it, make it yours a little. So what I like to do is basically the same thing as 3D, the same sort of setup. So I'm creating a new node 2D, call it world. Notice how it jumped over to that little graph. We need some images. So to go about the long way, I'm just going to drag some images in here because I didn't empty my delete folder this weekend. So I still have the images from getting ready for today. Just a couple squares. Right. And when we make those, once we make those squares move, we can just replace them with a different image if they have the same name. I called it player and ground. So as long as the other image is called player and ground, what we have to do is put it in the folder, and the computer's just going to load those instead. So that's what you want in your first draft is the sizes and types. So like these are 58 by 55 pictures in ping format. So that's what you would tell the art department. And then you start working with the squares, and before long, the art department's going to send you the first couple drafts of something that same size that looks a whole lot better than the plain square. I'll bring it up here. So there's my just drag it up here. It doesn't seem to want to drop in there. I don't think we did. We didn't do that. Okay. When we have mesh from Blender, we can do that. We can just drag it up there. So I'm drag it over here. Notice it showed up. There's a little image there. Here, scrolling in and out is zoom. If you hold Control and scroll up and down, or left and right on the wheel, or just click your mouse wheel and move around, that's your panning. If you zoom out, you can see like the screen size there. So I'll put it up there, and we can work with that. If I right click, okay, this button. So same place that mesh button where we converted the ground into static was before. If we click that, notice the top option, when we're most expected to click, is convert to a mesh instance. So that converts it to a mesh, which is vector graphics, but still like block transferring. We talked about block transferring way back in Pygame. And that's what GPUs do. We grab a whole bunch of data and move it all at once. So it's more effective to have it as a mesh. We can do more things with it. Such as if I go to the world and right click and search for character body. Instead of character body 3D, you can choose character body 2D and make the mesh a child of that, just like we did in 3D. Right click on the character body 3D and look for a collision shape. And there's a collision shape 2D. Doesn't have a shape yet, so if we choose a shape and maybe a rectangle shape, that's how we got that offset again, like we did with the mesh earlier. So I'm going to start selecting things. So I'm going to click this, and this is the one I actually want to be the player. That's our physical body. That's our logical body, and the collision shape is the physical body. I'll give it the same names we gave the one earlier. Call it shape. And then this is really just the graphics for it. So player and shape seem to be in the same spot, but our graphics are way off. But again, over here on the right, there's our transform data. A little bit shorter because we only have X and Y, which means we only have one angle of rotation. And then only two scale values. I'm just going to type in 0, 0. Now all three of those are lined up. And make sure I move the parent object. So I'll grab that. And it doesn't have very good move options. So I'm going to switch to the move tool here. There's a way to do it with the cursor, but I found over here some 2D, Godot 2D. It's just easier to use the switch to the move and scale tool 2D. And the buttons are right there. They're easy to click, and we can't really shut those buttons off. They're always right there. So we'll put our character in some starting position. Same thing for our ground too, right? For the world, just like last time, our ground's not going to move. Actually, let me do this. Before we even get into the ground, I'm going to select that player, click the script, and again, the basic movement script template is starting there. So if we hit create, notice we have speed and jump velocity, physics set up, gravity's already turned on. So we have gravity and jumping. So there should tell you kind of what the default thing it's leaning towards is, right? Actually, save it, play this now. Using that default script, I run that, save it with that name. We don't have to have a camera this time because it's obvious what the camera view is for 2 dimensions. but gravity's already applied, so it's falling down. So it kind of defaults to a platform. That's why I brought 2 squares, so we can set up the ground. Which, just like last time, that one's going to be static, right? So I'll go up to the root node, create a new node to build into a scene, and this time search for static, and choose static body 3D. I'll call that ground. And have this ping. I'll just drag, whoops, not that one. Ground. Take that image. Okay. Drag the green one in. And with it selected, it's probably easiest to do here. Convert that to a mesh, which is much, much better. We could work with that image the whole time, but the mesh is better. So you want to go ahead and form that. And if we convert it to a mesh, then we're doing the same thing in 2 dimensions and 3 dimensions. So there's more consistency. Make that a child of the static body ground. For consistency, I'll rename it graphics. Because we have multiple parts making up that ground. The logical component, the graphics, which again are in some arbitrary spots, so I probably want to put them at the same spot as the logic, or the code will have that character being, instead of being offset. But you can probably come up with all sorts of uses for offsets, right? Like a sword. Your sword isn't going to have the same origin as your player. It's going to be offset slightly in the shield. So sometimes we will want to offset things from that. But it changes situational. That's why we're mostly looking at the tool, because we need a situation to know how to answer any of those questions. Just why replicating some of those early arcade games is a great way to get practice. Then we need a collision body. So we search for collision shape 2D. There's multiple ways to do this. The tutorial I put in there might give a different way, but this is what I like to do so that they're consistent. Notice how our collision shape does not match up with what that is. That needs to be a platform, so I'm going to go up to the top one, move down here, like where would be a platform. Then we can scale that out. Right, maybe grab the scale tool, stretch that out a little so we have a longer platform down first. Move tool or something like that. Make sure our player is definitely going to fall onto that. Yep, like that platform. The collision shape is a little off. So from the player, the graphics are that big, the collision shape is way there in the middle. But if we zoom in on that, you can see there's a little handle. You just grab those handles. Here's where you put the cursor. Switch back to the cursor to select and just grab those handles and move to the shape you want. Hopefully this seems very straightforward. Seems fairly straightforward. We're not entirely wrapping a 3D object, so our collision shape is a little easier. And we scrolled where the mouse is. So you can always zoom out, put your mouse someplace different, and you scroll in to where the mouse is. So if we want to go down to the platform, put our mouse down there by it, and just grab those handles. Set up our collision shape. So, got collisions, the graphics, and the logic. The 3 minimum parts. Before long, we'll be adding in lots and lots of other things, but there's the 3 minimum. Left and right controls work just like before. It defaults to a platformer, so up and down doesn't do anything, but jump does. So we can probably put at least a second platform in here. And I'm just gonna copy this, so I'll grab that, copy and paste. Except notice how it made the second platform a child of the first. I'm gonna grab that and drag it all the way up here to the world, the root node. That way they're separate platforms. They're not dependent on each other. And I'll just select one of them and move it just like that. Move tool. Oh, why is it way down there?
I just did.
And big. So it copied that scale. Oops, not a 0. It copied the scale that we had on the first one, and then made it a child of it, so it was scaled that much bigger than the parent. Put it up here. Something like that'll probably work. Zoom in and then use the scale tool, and I'll just stretch it out a little. Probably maybe make that jump. I don't know how high it's jumping. Something like that. And when we run it, or left and right, which we can change to A and D. Last time we gave it useful names. I'm just going to go to the project settings, and on the input map, instead of making new ones, I'm just going to go to that left and right, UI left, and add the A key, and UI right, and add the D key. That way we don't have, whoops, D key. I said a few minutes ago, I'm still not used to that. I always want to hit enter. And I assume at this point, I long ago started assuming that I'm never going to get used to that. One of those things is never going to quite click in my mind. So instead of making a new input, I just added the A and D key to the arrow key, arrows. So now it should be able to use those. So left and right, jump. You can't jump high enough to get on the other platform. So our jump's too small. So I need to change that. I might have to try a few numbers to find it. So I'm going to switch those constants to variables. And at export, so now jump velocity. Oops. Oh, spell export correctly. So now, if we select player, jump velocity shows up on the inspector panel, and we can try different numbers. And notice jump's negative, which means positive. Y must be downward. Give that a run, and we can try values in the inspector until we think it's high enough to make that jump, but only just barely high enough. So you can see here probably a lot better with multiple screens. Let's try twice as high, see what it uses. Apply that value. That's way too high. Gonna make a platform game way too easy if we can jump that high. So let's go up in small increments. Was started at 400, so I'll go up to 500. Oh, I closed it. I guess I'd have it. That looks like it might just barely make it if we jump at the right time. If we jump at the right time, it'll make it, but if we jump,
There's a little bit of forgiveness.
a little bit of forgiveness there, but it's really close. We still fall off. So depending on how hard we want to make it. So
Plus, that leaves you open to make jumps a little bit harder later on.
yes,
If the first jumps have a little bit of breathing.
yes. Because we just have one jump up. Well, I can't fall down there. I should probably move that other platform to the right. The debugging stuff. 2 platforms is enough to see the basic idea there, right?
It also seems like it ping pongs off the second platform when you smack into it.
Yes,
Like, it bounced back off of it whenever
it does. So that's the move and slide again.
Physics engine.
then stop. If another body is character body or rigid body, it will be affected by the motion. So momentum transfers to multiple things. Like, although a marker up against the wall, all the wall can't move, so all the movement goes into the pit. But if I throw two markers into each other, so it's on the right, black's on the left, if it shows up on the camera, the movement transfers in between them. Or I guess one of the famous physics experiments, throw a tennis ball in front of a train. Don't do that. It will launch the tennis ball through it, push the tennis ball through an oak tree. Big full grown oak trees. Don't do that. But the movement if there's two things moving, it will go between them. But all the physics has to apply to that one. Yeah, the moment just a little bit of the train's mass going into the tennis ball is a lot. Oh yeah, the same thing is like putting a tennis ball on top of a basketball and dropping. Or beer can is a common game with it. Beer can on top of a basketball, and then drop the basketball, and it bounces up higher than what you dropped it from. And the game is catch the beer can. But it works well with tennis balls too, without referring to alcohol, I guess. And without the train thing that is very, very dangerous. Let's see if that worked. Maybe where is this like a hard jump? So that's one of the things about platformer games. Whoops. So I completely missed the jump. Restart that. That might be too far. So we go back up to 500 here. And avoid things like what he was mentioning where it bounced off there. Okay, that's I guess I just was clicking at the wrong spot. We're trying 450 again. I was looking for some place that would make it hard, right? That's our fancy debugging stuff there, so I missed it again. Maybe a reset after our Y value gets too far. Like, I don't know what the size of that screen is, but right now, is there a roller here? Oh yeah, there's a roller, so looks like that blue line's there's 1,000. Oh, well, I guess it's reading from my screen. I assume it's 1280. It looks like it's about 1200. We could just set a condition so that if our Y position dot Y is greater than 1500, restart the level. I mean, easy thing. We'll get to some of that soon. I'll put it back to 500. That way I can actually make that jump. But or 475, see if that's close. That's the debugging part of platformer games, though. Oh, I know what I'm doing. I should watch the computer, not the Zoom call. That worked much better. I keep doing that. It really shows up there in the game, but yeah, you want it to be just barely enough to make it to be a fun platform. Not the first platform, obviously, but by the time you get to the end, you want it to be a bit of a challenge. And all that physics stuff. This is the one we're going to spend the rest of the semester on. It's much bigger, fancier than the ones we worked before. Right? Virtual reality and augmented reality showed up today. Those definitely didn't show up in the game engines we've seen earlier this semester. I did get approved to buy a bunch of VR, so I have a VR lab coming somewhere. By taking the 248 class with me in the spring, we will have a bunch of VR see there. I think we'll have time to see at least a little bit, and I can bring in my headset, load stuff in. That fits in the 248 class a bit better anyway. And the 248 class is where we just sit down and make games over and over and over again. Like your final project is one big game that can fit in the class.
That's like game development too, or whatever.
Yes, advanced game development simulation. We'll also look at some simulation stuff that would be like what the engineer needs. that physics stuff because we have it here. So this is gonna accurately portray what engineers need.
So what does that course use the Godot engine or does that use a different thing?
I'm gonna use Godot. I don't know if they've developed it for Ivy Online now. People have been complaining about it. 148 is still using Unity and after it,
Needs to be updated.
yeah, it needs to be updated. They're going to change to Godot too because Unity is just way too much to throw people in with no previous game experience. They go to just start following Unity tutorials on day one that are like 6 years old, so they are seriously outdated. And nobody asked for an update this year, so hopefully the update I gave them last year for Unity is getting the students through. But I think maybe they just gave up and started doing that other stuff. But it's a lot for day one. Godot has a much easier learning curve. We got started pretty quick. You're gonna want to click around on stuff. So take some of those things, see if you can get some stuff working, and mostly just start by clicking around, getting familiar with that big complicated interface. Take note of where words are, where different menus are, click around. There's a lot there. It's dynamic, it changes. So it takes a while to get used to it. You just want to start doing that and some of the stuff like we did in class, take those couple steps further. Make an obstacle for that 3D character, or make a couple more platforms on that 2D one, which we went through quickly. Someone to finish by 4:50, so still an hour to do stuff. Please use the hour productively, and then we'll get started into just making games with that on Wednesday. Probably an early arcade game that can fit in the class. I'm moving Space Invaders again. Now we're not worrying about the logic. We're just looking at the new syntax. Probably something different. It's a very good Space Invaders. We don't want to do the same game twice in a row. That would work. I think I might be able to fit the level 1 Mario in, cover tile sets. The original Zelda take about a month and a half.
Oh,
It'd take me about a month and a half. Probably take longer than that to actually show it in the lecture. If I just sat down and started doing it, I would have time to process. I would do it for like 10 hours a day. But
It's also, if you're doing the full game, it's also a decent sized thing, so.
yes. Yes.
we probably need to get those GPU.
We'd want to match Nintendo graphics. If we're remaking Zelda, we want to remake the original Zelda. The 8-bit graphics. Get it looking right. But otherwise, if y'all have any questions, let me know. I'm always happy to help. I'll see you on Wednesday. We're going to be working with this game engine the rest of the semester, so we have longer than the previous ones. We have a whole 4 weeks to learn this one. Or yeah, get a quick introduction to it. I'll see y'all on Wednesday. Oh, and remember, for your project, for what's due about your project now is just tell me what you're going to do. Write a paragraph and tell me what you're going to do, and then that paragraph is going to be part of the final, the proof of concept proposal that you're building up to. So it's the first step in that. Otherwise, I'll see you on Wednesday, everyone.